Hi guys, before we start our mathematical journey today, I am Teacher Dong and I would like you to hit the subscribe button and the notification button for more videos. This time, we're going to talk about graphs of quadratic functions. In this specific topic, we will explore first the different terminologies that we are going to encounter in graphing quadratic functions. Then, we're going to explore as well the different values that we need to solve before we can graph quadratic functions. Now, for you to be able to follow the steps in graphing quadratic functions, I would like you to prepare your graphing paper or any clean sheet of paper. Let's start. First thing is, in this activity, we need to use the table to find the words indicated below, and afterwards, you will be searching for the meaning of these. But, okay, so you can do this in your vacant time. Alright, so but in this topic, we're going to talk about the following terminologies and define them as well. First, we have the vertex, axis of symmetry, parabola, minimum point, maximum point, and vertex form. Alright, so the question is, what is the graph of quadratic function? So the graph of quadratic function is parabola. Parabola is a U-shaped curve. So what do we mean by that? We just follow the shape of letter U. So just like what you are seeing, we have pink parabola here and green parabola here. The one is opening up, the one is opening down. So this is the best example of a parabola. Alright? So, before we can actually graph, we need first to solve for the vertex, h and k. It is a point. So just like what you are seeing here, so this is the vertex, and this is also the vertex of the green parabola. Now, what is a vertex? Vertex is the turning point of the graph. So just like what you are seeing, the leg of this graph, the pink graph or pink parabola, okay, that goes up. So if you are going to follow the direction going down, okay, so the graph will turn up because of the vertex. That's why we are calling it the turning point of the graph. Now, it contains point. So the point is h and k. And there are formulas that we can use to solve for the values of h and k. So the first formula is h equals negative b over 2a, and the second formula, k is equal to 4ac minus b squared all over 4a. So you have to take note that from the standard form, first is you will have to arrange it in standard form of the quadratic function. Then that is the time that you can actually get the values of a, b, and c that we can use in solving for h and k. The next thing is, if the parabola opens up just like the pink graph that you are seeing, the lowest point is what we call the vertex or the minimum. And if the parabola opens down, the vertex is the highest point or what we call the maximum of the graph. Now, take note that if the parabola opens left or right, it is not a function. Again, if the parabola opens left or right, it is not a function. So how did we say that? So the graphs that you are seeing, they are opening up or down. So those are supposed to be the direction of the opening of the graph. Why? In the previous lesson, we actually checked the different graphs wherein we use the vertical line test to test if it is a function. So just like the pink graph that you are seeing right now, if you will be drawing that vertical line test, so the condition is that the vertical line must only touch the graph at exactly one distinct point. Now, so how are we going to know if it is not a function? If the parabola opens to the right or opens to the left, so as you can see, if we are going to test this graph using the vertical line test, the vertical line touches the graph at two distinct points. So therefore, this is not a quadratic function. So let's have the second one. So the vertical line also touches the graph at two distinct points. So therefore, this is not also a function. So how are we going to know? When you draw the vertical line, it must only touch the graph at one distinct point. Next, so before we proceed, the first value that we need to solve is the vertex. Second, how are we going to know the opening of the graph? Is it opening up or down? How? Let us first consider the standard form of the quadratic function, which is f of x equals ax squared plus bx plus c. So that is the standard form that we need to follow, and also this is the standard form that we need so that we can get the values of a, b, and c properly, that we are going to use then in solving for the coordinates of the vertex. Now, the parabola will open up when a value is positive. So what is the value that we need to look for? The value of a. Look at the value of a. So if the value of a is positive or greater than 0, the graph opens up. The other way around, the parabola will open down when a value is negative or a is less than 0. Again, okay, the parabola will open up if a is positive or greater than 0. And the parabola will open down if a value is less than 0 or simply negative. So we have to take note that a must not be equal to 0. Why? The quadratic term will be removed if a is equal to 0, and it's not anymore a quadratic we have without the presence of the quadratic term. Next value to solve is the axis of symmetry. But before that, we have to take note that parabolas are symmetric. So if we drew a line down the middle of the parabola, we could fold the parabola into half. So the blue dotted line now is what we call the axis of symmetry. That line makes the graph of the quadratic function, which is the parabola, symmetrical. Alright? So what is the formula in getting the value of the axis of symmetry? X is equal to negative b over 2a. Take note that in the vertex, okay, it is the same as the value of h, which is negative b over 2a. So it simply means that you don't need anymore to solve for the axis of symmetry because it was already solved previously when we solved for the value of h of the vertex. Now, if we graph one side of the parabola, just like this leg, we could reflect it over the axis of symmetry, okay, axis of symmetry, to graph the other side. So again, the axis of symmetry always passes through the vertex of the parabola, just like what you are seeing on the illustrations. Next, so we're done. Let's have now the steps in graphing quadratic functions. So the first step is find the vertex h and k. Again, these are the formulas. H is equal to negative b over 2a and k is equal to 4ac minus b squared all over 4a. Step 2. Find the axis of symmetry using x equals negative b over 2a. Now, just like what we are saying, if you are able to solve already the value of h, it's also the same as the value of x, or the axis of symmetry, because they do have the same formula. Next, step 3. Step 3, if you already have the vertex and if you already have the axis of symmetry, you can now construct your table of values using the vertex and using the axis of symmetry. Then if you already have the table of values, you can now draw the graph. Next, let's have the first example. Graph f of x equals negative x squared. The first thing that you have to check if it is a complete or incomplete quadratic function. So as you can see, we only have the quadratic term of the quadratic function. Therefore, we can say this is incomplete because we don't have the bx term, or the linear term, and the constant term. The next question is it already arranged in standard form? Yes, it is already arranged in standard form. Then the next thing is we need to get the values of a, B, and C. So the value of A is negative 1 since the linear term and constant term are not present, so we can actually equate B to 0 and C to 0. Alright? Next, step 1. Let us solve for the vertex H and K using the formulas. H, we have negative B over 2A, while K, we have 4AC minus B squared all over 4A. Please ready your calculator because you can already use your calculator to directly solve for the values of H and K. Then let us substitute the values. We have negative times the value of B, which is 0, over 2 times the value of A, which is negative 1. Then for K, 4 times A, negative 1, which is, and then C, we have 0, minus the value of B, which is 0 as well, square all over 4A. Now, you can already solve this you can solve this manually, or you can solve it directly on your calculators. So if we will be solving it manually, it is negative 0 over 2 times negative 1, which is negative 2. Alright, so if we were going to multiply negative times 0, it is still 0, and then 0 divided by negative 2 is 0. Therefore, H is 0. Next, let us simplify. 4 times 1 times 0, it is 0. 0 property says that if we multiply values to 0, the answer is always 0. Then 0 square is 0. All over 4, the value of A, which is negative 1. So 4 times negative 1 is negative 4. 0 minus 0 is 0, divided by negative 4 is also 0. Your K is also 0. Therefore, your vertex is 0, 0. Next, we're done with the vertex. Let us now have the axis of symmetry. You have to take note that H is equal to X. Therefore, the axis of symmetry is also 0. We already have the vertex and the axis of symmetry. Next, we can now actually construct our table of values. So, in the middle part, you have to write the point of the vertex. Okay, we have 0 and 0. Then, how about the values of X on the right and values of X on the left? Just associate the value which are more than 0 to the right and then less than 0 to the left. Okay, consecutively. So, to the right, we have 1, 2, 3. And to the left, we have negative 1, negative 2, negative 3. Then, we're going to solve now for f of 1, f of 2, and f of 3. F of 1 is equal to negative times 1 square. Then, f of 2, we have negative times 2 square. Then, f of 3, we have negative times 3 square. So, 1 times 1 is 1. Then, bring down negative 1. Negative times 1 is negative 1. Therefore, f of 1 is negative 1. Next, 2 times 2 is 4. Times negative 1, it is negative 4. Therefore, f of 2 is also negative, is also a negative integer, which is negative 4. Next, 3 times 3 is 9. Bring down 9 times negative 1, it is negative 9. So you have to take note that the parabola is symmetrical. So therefore, whatever values we have here are also the values of the x's on the left of 0. So f of negative 1 is also negative 1. F of negative 2 is also negative 4. And f of negative 3 is also negative 9. Alright, so we are able to complete now the table of values. The next thing is we can now graph using these points. Alright, so let's start with point 0, 0. So point 0, 0 is also the origin. Alright, you have to take note as well that since A is equal to negative 1. Therefore, the graph opens down. Alright, so the first point is 0, 0. Next, we have 1, negative 1, and then negative 1, negative 1. Let's start first with 1, negative 1. So 1, negative 1 is this point. Then negative 1 is this point. You have to take note, no? You have to take note that you have to get first the value of x, okay, on the Cartesian plane, and then you have to get you have to align it with the y, okay, so that you can actually locate the exact point. Next, let's have 2, negative 4 and negative 2, negative 4. Let's start with 2, negative 4. 2, negative 4 is this point. Next, we have negative 2 and negative 4. Alright, this is the location. Lastly, let's have 3, negative 9 and negative 3, negative 9. This is 3, negative 9, and this is negative 3, negative 9. Now, draw the graph. You have to be careful in drawing, and then you have to take note as well that the parabola is a U-shaped. That's it. This is now the graph of f of x equals negative x squared. Then the next thing is we will be using another color for the axis of symmetry. The axis of symmetry is x equals 0. So this will now be our axis of symmetry. Let's assume that this is the perfect graph of f of x equals negative 2. So our axis of symmetry is x equals 0. So that's now the graph of f of x equals negative x squared. Now let's proceed to the next example. Graph f of x equals x squared plus 4. So the first thing is check if it is a complete quadratic function. And based on what we are seeing, it's not a complete quadratic function because the linear term bx is not present. Then the next thing that you have to check if it is arranged already in its standard form. And based on what you are seeing as well, it is already arranged in standard form. Then the third is you have to identify the values of a, b, and c. Why? Because we need them in solving for the vertex and the axis of symmetry. Now, the value of a is 1, and the value of b is 0, and the value of c is 4. Alright, next, let us solve for the vertex using the formulas for h and k. So for h, it's negative b over 2a, and then for k is 4ac minus b squared all over 4a. Substitute the values. So negative, so b is 0 over 2 times 1. Then for k, it's 4 times 1 times 4 minus 0 square all over 4 times 1. Next, so this is, since the numerator is already 0, 0 divided by 2 times 1, it's 0. Then here, 4 times 1 times 4 is 16, and then 0 square is 0 all over 4 times 1, which is 4. 16 minus 0 is 16 divided by 4, it's 4. Therefore, our vertex is 0, 4. Then the next thing is So we are saying that h is equal to x, therefore the axis of symmetry is also 0. They are just the same. Now we are able to have our vertex and our axis of symmetry. Then, before we proceed, what is the opening of the graph? As we can see, the value of a is positive, therefore the opening of the graph is going up. It opens up. Now, let's graph using the vertex. So the vertex that we got is 0, 4. We are now going to associate values of x to the right of 0 and to the left of 0 consecutively. So 0, then we have 1, 2, 3, and on the left we have -1, -2, and -3. We will be solving for f of 1 equals 1 square plus 4, f of 2 equals 2 square plus 4, then f of 3 equals 3 square plus 4. So 1 times 1 is 1, plus 4 is 5. Therefore, f of 1 is 5. And f of -1, since the parabola is symmetrical, is also 5. Next, 2 times 2 is 4. 4 plus 4 is 8. Therefore, f of 2 is 8. And f of -2 is also 8. Next, 3 times 3 is 9 plus 4, 13. Therefore, f of 3 is 13, and f of -3 is also 13. Next, we already have our table of values. Let's now graph. First is we have the vertex 0, 4. So from 0 to the y-axis, 4. This is 0, 4. Next, we have 1 and 5 and -1 and 5. 1 and 5, then -1 and 5. Next, we have 2 and 8. We also have -2 and 8. So 2 and 8, then -2 and 8. Alright, next, we have 3 and 13, and -3 and 13. And 13, then we have -3 and 13. Alright, now we can now draw the parabola. So according to definition, the parabola must be a U-shape. So let's now say that this is the perfect graph of the parabola. So therefore, this is the graph of f of x equals x squared plus 4. Now let us draw the axis of symmetry. So the axis of symmetry is 0. X equals 0. Axis of symmetry passes through the vertex of the parabola. So therefore, this is x equals 0. This is now the graph of f of x equals x squared plus 4. Now, let's proceed to the last example. We have f of x equals -x squared plus 6x minus 9. Right, so let's start checking. Is this already arranged in standard form? Yes, as you can see, the quadratic term is here, the linear and the constant terms are also here. Then the next thing is check if it is arranged in standard form. Yes, it is. Then lastly, identify the values of A, B, and C. So the value of A is negative 1, then the value of B is 6, and the value of C is negative 9. Then as you can see, A is negative 1, right? So if A is negative, therefore the opening of the graph is going down, or the graph opens down. Let us now solve for the vertex H and K. So let's start with H, which is negative B over 2A, and K, which is 4AC minus B squared all over 4A. Substitute the values, negative times 6 over 2 times negative 1. Then here we have 4 times A, which is negative 1, and C, which is negative 9, minus B, which is 6 squared, all over 4 times negative 1, which is the value of A. Simplify, negative times 6 is negative 6 over 2 times negative 1, negative 2. So negative 6 divided by negative 2 is positive 3. Then for K, 4 times negative 1 times 9, negative 9 is positive 36. Minus 6 times 6, which is also positive 36, all over 4 times negative 1, negative 4. So 36 minus 36 is 0, divided by negative 4 is 0. Therefore, our vertex is 3, 0. Next, so we are always saying that H is X, therefore X is equal to 3. We already have the vertex and we already have the axis of symmetry. We can now complete the table of values. In the middle, we have the vertex, which is 3, 0. So the numbers that are greater than 3, we have 4, 5, and 6, and less than, we have 2, 1, 0. Then we will be solving for f of 4 equals negative times 4 squared plus 6 times 4 minus 9. Then we have f of 5 equals negative times 5 squared plus 6 times 5 minus 9. And then lastly, we have f of 6 equals negative 6 squared plus 6 times 5 minus 9. Then simplify. 4 times 4 is 16. Negative times 16 is negative 16. 6 times 4 is 24 minus 9. So negative 16 plus 24 minus 9 is negative 1. Then here we have 5 times 5, 25 times negative 1, it's negative 25. 6 times 5 is 30 minus 9. So what will be the answer? It is negative 4. So f of 5 is negative 4. Then lastly, we have 6 times 6, 36 times negative 1 is negative 36, plus 6 times 6, this is 6, 6 times 6, 36 minus 9. So therefore, it is negative 9. So f of 6 is negative 9. Symmetrical, f of 2 is also negative 1, f of 1 is also negative 4, and then f of 0 is also negative 9. So we already have our table of values. We can now graph f of x, or graph f of x equals negative x squared plus 6x minus 9, starting with the vertex 3, 0. So 3, 0 is here. This is 3, 0. Next, let's have 4, negative 1 and 2, negative 1. So 4, negative 1 is this. Then we have 2, negative 1. Next, we have 5, negative 4 and 1, negative 4. So 5, negative 4, then 1, negative 4. Then we have 6, negative 9 and 0, negative 9. 6, negative 9, then 0, negative 9. Alright, so we already have we are able to plot the points. This time, let's draw the graph. So the graph must be smooth and continuous, and it must be a U shape. So let us assume that this is the perfect graph. So therefore, this is now the graph of f of x equals negative x squared plus 6x minus 9. And the axis of symmetry is x equals 3. Alright, we're done. So what you have to remember in graphing quadratic functions, first you have to solve for the vertex using the formulas for h and k. Next, axis of symmetry. Axis of symmetry is also the value of h. Then third is you have to construct your table of values. Then lastly, that's the time that you can graph the quadratic function. As simple as those steps. So it's not complicated and it is easy to do. Alright, so I hope that you have learned a lot for this session or for this mathematical session. Again, this is Teacher Dong, and don't forget to hit the subscribe button and the notification button for more educational videos. Have a great day.